In this video, we're going to simplify expressions of radicals by adding and subtracting like radicals. So like radicals have the same index, and remember, index is what type of root you have. So is it a square root? Are they both cube roots? Are they both fourth roots? Okay, so it's the type of root. And the same radicand. And the radicand is what's inside of the radical. Let me make that a little more clear. So, for instance, if we had 5 cube roots of 2, that would be like with 4 cube roots of 2. However, if we had 5 square roots of 2, that would not be like with 4 cube roots of 2. Those are not like, because they don't have the same index. So those are not like. Okay? And then if we had 5 square root of 2 and 4 square roots of, let's say, any other number, 6, these are not like, because they have different radicands. So those aren't like. So like radicals are get their name from the same place that we talk about like terms. So remember, if we had 5x and 4x, if I add 5x to 4x, I would combine that to 9x. That same concept's here. If I have 5 cube roots of 2 plus 4 cube roots of 2, that would be 9 cube roots of 2. Notice we add or subtract each radical, or we added by adding the coefficients. We don't add what's inside of the radical. All right, so adding and simplifying radicals, you have 2 steps. One, you need to simplify each radical. So each radical needs to be in simplest form. So simplify each radical. Because you can't decide if they're like or not until it's simplified. And then step 2, add or subtract, depending on which one you're doing, each radical by adding or subtracting the coefficients. All right. So you don't add what's inside of the radical. What's inside of the radical stays the same. So if you look at our example up here, I had 5 cube roots of 2, and I'm going to add 4 cubes root of 2, which gives me 9 cube roots of 2. So let's do some examples. So again, we need to simplify each radical. So what I like to do is look at each radical individually, and decide, hey, is it simplified? And if it is simplified, then I don't need to do anything to it. If it's not simplified, then I need to simplify it. So let's look at example 1. 3 square roots of 2, that is simplified, because square root of 2 is not a perfect square, nor is it divisible by a perfect square. Let's look at the next term in there. So we have the square root of 50. Now I know that's not simplified because it's divisible by the square root of 25, and it goes in there twice. Right? The square root of 25 is 5, and I get 5 square roots of 2 when I simplify that one. Let's look at the next term. We have minus 4 square roots of 8. 8 is divisible by 4, which is a perfect square. So that can also be simplified more. So I'm going to take out the 4. So it becomes minus 4 square roots of 4 square roots of 2. Then I'm going to find the square root of 4, which is 2. And then negative 4 times 2 is 8. All right? So then what I'm going to do is I'm going to bring these other guys down. So that pot plus 5 square root of 2, bring that down. I'm going to bring this one all the way down to here. And I get 3 square roots of 2. So when I go to add this, I'm going to have 3 plus 5 minus 8. All right, and 3 plus 5 minus 8 is 0. So it's 0 square roots of 2, which is just 0. Can you imagine all that work to just get 0? So simplify each radical and then combine each radical by adding the coefficients. If they're like, they have to be like for you to do that. So let's look at the next example. Square root of 300, that is not simplified because 100 goes in there 3 times. The square root of 100 is 10. Then I have the minus the square root of 27. The square root of 27, that is not simplified because 9 goes in there 3 times. So I get 3 square roots of 3. And then the square root of 75, that's not simplified because 25 goes in there 3 times. Square root of 25 is 5. All right, now I look and I have the square root of 3, the square root of 3, square root of 3. All of those are like. Okay, all of those are like, so I can combine them. 10 minus 3 is 7, plus 5 is 12 square roots of 3. Okay, so simplify each radical, combine any that are like. They won't all be like, so we'll do examples where they're not all like. But if they are, you can combine them all together. All right, let's look at this next example. 8 square roots of x to the third. So that's not in simplest terms because 8 is a divisible by a perfect square, 4. X to the third, remember we're going to divide by 2 because we're doing a square root. If we're doing a cube root, we divide the exponent by 3. If we're doing a fourth root, we divide the exponent by 4. X to the third is not divisible by 2, but the next one down is 2, which is, and the remainder goes here. Bring down square root of 2x. The square root of 4 is 2, and then I divide that square by 2, and I get 1. So that's 2x square roots of 2x. So again, how did I get the first 2x? Square root of 4 is 2. 2 divided by 2 is 1, and x to the first power is just x. All right, let's look at minus x square root of 98x. So the x is going to stay on the outside here. 98 is divisible by 49, and it goes in there twice. And then x is to the first power. So that is already small enough where it's simplified. So it's going to go here. Because remember, when you're looking at the exponents of your variables, as long as they're smaller than the index. So the index of this one is 2, because we're doing a square root. And since I have just x there, it has an exponent of 1, which is smaller than my index. So that is simplified. I'm going to do the square root of 49, which is 7. And then I just bring that x down, 2x. So this came from that came from that. Now it looks like a mess there. Oh, Lord. Oh, Lord. She's erasing things. All right. Now let's look at the next one. So now I have minus 5. 72 is divisible by 36, and that's a perfect square, and it goes in there twice. X to the third can be split just like I did in the first term, where the x squared is going to go here, and the remainder is going to go there. So I'm going to have 5 times the square root of 36 is 6, and then the square root of x squared is just x, and then bring down the 2x. And then 5 times 6x is 30x. Let's forgot the x there. All right, so let's bring these other guys down. So 2x, square root of 2x, minus 7 square roots of 2x. Oh, 7x, excuse me. Let me write that again. So minus 7x square roots of 2x. Now what I want you to notice is these are like terms because they all have that x square root of 2x. So that all of them have that. So then I just have to combine the coefficients. 2 minus 7 is negative 5, minus 30 is negative 35, and then I just bring down the common radical in term they have. So they have an x square root of 2x. So simplify each radical one at a time, and then once you finish, combine anything that's like. So it's not only square roots that can be simplified and combined together, it's also cube roots, fourth roots, fifth roots, and multiple types of roots. So let's look at number 4. So for number 4, we're first going to take out, let's see, we're going to take out, that negative cannot be in the radical. So I'm going to take out a negative 1. All right, that's the biggest perfect cube that goes in there is negative 1. The cube root of negative 1 is negative 1. And then negative 3 times a negative 1, that's going to leave me a positive 3. All right, for the next term, let's see, 2 cube roots. 162 isn't a perfect cube, but it is divisible by 27. And it goes in there 6 times. Let me double check that. 162. Yes, 6 times. The cube root of 27 is 3. So I get 6 cube roots of 6 because I did 2 times 3, which is 6. So 27 went to 162 6 times. The cube root of 27 is 3. 2 times 3 is 6. All right, let's look at the 3 cube roots of 81. Oh, 81 is also divisible by 27. Whoops, I left out part of my problem. 3. Oh my goodness, hold on, let's try this again. All right, 3 cube roots of 27, and it goes in there 3 times. The cube root of 27 is 3, so I'm going to have 3 times 3 here. Cube roots of 3. 3 times 3 is 9, and I bring down the cube root of 3. So 27, which is a perfect cube, goes into 81 3 times. The cube root of 27 is 3. 3 times 3 is 9. All right, so now if we look, the only two that are like is this term and this term. The plus cube roots of 6 can't be combined with any of the other two because its radicand is 6 and the other two have a radicand of 3. So I'm going to combine 3 plus 9 and get 12 cube roots of 3. So my final simplified expression is 12 cube roots of 3 plus 6 cube roots of 6. Okay, so that's the simplified expression of that problem. Okay, remember, you can only combine radicals that have the same index and the same radicand. All right, these two, that's as simplified as this expression can get. All right, let's look at number 5. Let me see, 4 6 root of 3 is already simplified. All right, let's look at the next one. Plus 2 fourth root of 32. I'm pretty sure 32 is divisible by 16. Let's see, 16 goes into 32 twice. And the fourth root of 16 is 2. So times 2, fourth root of 2. 2 times 2 is 4. And I really should have left myself more space to do these problems underneath there, but I'm trying to color code them so you can see where I'm at. All right, let's look at the next one. Minus 3. Whoops, no, we're doing 6th root. So 6th root. 2 to the 6th power is 64, and 64 goes into 192 3 times. 192 divided by 64 is 3. All right, 6th root of 64 then is 2, and then 3 times 2 is 6. All right, let me bring this guy down so I don't forget about him. I was looking at that and I'm thinking, you know what, Miss Carr, you're going to forget all about that guy. All right, let's look at the next one. Oh, it's 192 again. All right, so 64 and 3. The 6th root of 64 is 2. All right, minus 4, 6 roots of 3. So the plus 4 fourth roots of 2, it can't be combined with any of them because it doesn't have the right index or the right radicand. For the other ones, I'm going to do 4 minus 6 minus 4, which is negative 6 cube roots. Nope. These should have been 6s. Look at that. That should have been a 6. That should have been a 6. And this should have been a 6. You probably were yelling at the computer screen the whole time. Miss Collier, you have the wrong index there. All right. So this one, and this one are now like. I brought down 4 roots of 2. 4 minus 6 is negative 2, minus 4 is negative 6. 6 roots of 3. So for adding and subtracting radical expressions, you have to have like radicals. To determine if they're like, first you have to simplify. So simplify each radical, then add or subtract each like radical by adding or subtracting the coefficients.